Hello, everyone. The topic of my presentation is license to inspect, which, as you can see, is James Bond inspired. But today we are going to be auditing an ML pipeline for open compliance. A little bit about myself. I usually code in Python. I'm a Python enthusiast. I've spoken at multiple different conferences, including multiple PyCons. And I've been working on natural language processing since 2018. So basically almost as close to the 2016 start from Stanford. I do fun experiments, and sometimes they are like social with data, Python and language models. Because I believe, and this is in my bio, it was in my bio in 2018, that the human condition is encoded in language, just as science and math. And one day we will be using language models as we use any sort of calculators, which is true today. So let's start with why this matters. 78% of people who use machine learning models, they use open source machine learning models, but they never verify the licenses. Now, this is not laziness. It's mostly because when you're setting up like an ML pipeline, it actually has multiple components. It's not one single thing. So it has like 3 or 4 different layers. And as you can see over here, the first one is probably the data sets. The second one is mostly they use pre-trained models, at least 75%. The third step is like all of the infrastructure that you use, whatever cloud you basically deploy it on. And the last one is what happens when someone leaves your team and they had access to all of the attributions. Oh, we use data set from X. We use data sets from Y source. And this is the pre-trained model that we basically trained our model on. So what happens is, if you don't do all of this analysis before you deploy into production and your model goes to the customer, you're going to have lawsuits at the end of your deployment, and that's going to be like extremely expensive for your organization. So today I'm going to take you through like one case study, and that case study is a fake news detector. The first step is when you scrape news. Now this is an extremely high risk operation because you don't know where you're sourcing your news articles from, whether they are copyrighted, whether they are actually, because sometimes content is public, but it's still copyrighted. So you need to be able to attribute it. The second one is labeling data. Most data that is labeled today has been labeled using Amazon Mechanical Turk operations, and you don't necessarily know what their methodology was or what sort of labeling training was given to the people who were actually labeling the data. The third step is when you're using pre-trained models. For instance, most people, at least till like the last couple of years, used to fine-tune BERT. And in this case, we are going to use this example of fine-tuning BERT. The fourth step is when you deploy the API. So that will be on like some sort of a cloud provider, some cloud infrastructure. And the last one is when you're flagging content. So basically, this is a fake news detector. So we are at the end, we are going to flag the content as, oh, this is fake news. So in terms of data collection, say you scraped like 50,000 articles, and they're like from online sources like CNN, BBC, and blogs. So you think that's open data, that's public data. But we have violated the TOS for like all of these sort of sites because no one actually goes through all of the TOS. But you actually have to if you're going to deploy a model based on that data. The second one is when you're setting up any sort of pipeline to label the data. Say you use Amazon Mechanical Turk, but you never set up a proper attribution system. So you don't know who owns the IP. The third one is when your model training on top of a particular pre-trained model. For instance, you are pre-training, you're post-training or fine-tuning BERT base. BERT actually uses Apache 2.0, which is great, but what that basically means is you have to add all of the attribution chains to whatever model comes out of BERT base. You deploy to AWS as a REST API. So the documentation is okay, but we never checked the export controls. And the last one is content moderation. When you have to make sure that all of the things that you are flagging as fake news are actually fake news. So how do you prevent this? So I have come on this 5 checkpoint audit framework of sorts. The first one is data provenance. The second one is model lineage. The third one is attribution chain. The fourth one is make sure you know what use restrictions are in place. And the last one is liability mapping. First one, data provenance. So when you're looking at data provenance, the key questions to ask are what are the terms of conditions of the scrapped websites? Those are the pop-ups that basically pop up on your screen and you just like scroll through and you click on accept and then you go and read the article. Reading the article is fine, but using the article in any other way is going to have a lot of conditions associated with it. Does the robots.txt allow scraping? So I don't know how many of you over here have actually used scraping, beautiful soup on Python. So you're supposed to not scrape websites where the robots.txt says, oh, don't scrape this. If you scrape that data and you use that data in your training, it will be flagged later on. Are those news articles copyrighted? It could be public information, but it could be copyrighted. And what license applies to the data set? For instance, scraping CNN articles. Every CNN page is like free to open, and it's probably accessible using any sort of beautiful soup sort of script, except it's copyright infringement because this news content is protected. So the solution is to use licensed news APIs or data sets with clear terms. Sometimes what happens is a lot of organizations, including universities, team up with these news organizations, and they come up with data sets that are specifically for open source operations of sorts. So in that case, that data set will be created in collaboration with all of these entities, and they will not have the same terms of conditions that normally scraping an article will have. And you can use those articles for your studies. The second checkpoint is model lineage. The key questions to ask is, what license covers the base model? All of these base models that you're basically fine-tuning on, the pre-trained models, they all come with a license, even if they are free to use on Hugging Face or anywhere else, even if they have open sourced all of the model weights, they do come with a license. So you have to make sure that you know what license they're using so that you can basically cover the attribution chain that is required by the license. So what data was it trained on? If you're using a pre-trained model, you have to understand what data it was trained on. All of these things are very recent. The compliance aspect of models and pre-training and data are newer to the fields than they have been before, because everything else that happened before used to be research. So there used to not be a lot of customers at the end that you were going to serve, which means a lot of the pre-trained models, which are older, even including BERT, you don't actually know what data it was trained on, especially like the Amazon Mechanical Turk label tasks. The third question is, do fine-tune weights inherit restrictions? So this aspect is interesting because it's like, well, there's like a bunch of weights that a certain model was trained on, and people have open sourced those weights, except they have a bunch of restrictions because of either their geographic conditions or like where the data was scraped from or who was the person and what sort of license applies to the pre-trained model. And the last one, are there commercial use limitations? A lot of open source models will be open sourced and they will say you're not supposed to use it commercially. Or there is some sort of complex attribution that is required when you start using it commercially because they have open sourced it for you. So sometimes the terms of conditions are like, oh, we have open sourced these models only for research or like any sort of studies, but not for commercial use. So for example, the scenario is using BERT from Hugging Face. It's like the easiest thing you could do in the world, except it has an Apache 2.0, which requires attribution, and the training data is unknown because of how old the model is. It was all very interesting like a couple of years ago when they did like a bunch of things, and they were like, well, this is such a smart model. We have all of these tasks that we have lined up on an Amazon Mechanical Turk, and it performs really well with respect to all of these tasks, except there is no good source for where they actually scrape that data from. So the solution is to document the base model. You have to make sure that everyone understands, including your customer base, that this is where your base model is from. And you have to verify the training data compatibility. Checkpoint 3, attribution chain. So who labeled the training data? Are all the contributors of the training data credited? Where is the attribution documented? This is an important question because depending upon the context of where your data actually came from, people could have different understandings of the same task. And the task could be as simple as fill in the blanks. Because in a certain context, they would have a limited vocabulary of a certain language, and in another context, they would have a completely different vocabulary of a certain language. So those two groups of people would perform this task differently. So you have to understand who labeled the training data. Are all the contributors credited? Whether all of this crediting attribution is documented somewhere, and does deployment preserve the credits or not? For instance, people use crowd workers on Amazon Turk. And there was no formal attribution in place because this is like Fiverr work. You basically pay someone like $5 to label around 100 examples or something. And there is no formal training for how to actually go around labeling this. So you as a person could be putting up 100 examples on Amazon Mechanical Turk and saying, I just need these examples to be labeled as for their sentiment, like whether this is happy or sad or neutral. And the person who's actually doing the labeling doesn't actually understand the context of whether it's happy, sad, or neutral, or whether it's sarcastic. So that changes the sentiment. So you don't know if there's like any sort of formal attribution system in place. So you have to create an attribution.md with all of the contributors and sources. Very difficult if you actually use Amazon Mechanical Turk, because all of the workers there will actually do all of the labeling for like $5. Checkpoint 4, use restrictions. So whenever there is a model that has been open sourced, you have to make sure if there are like non-commercial clauses. A lot of companies like Meta and even Salesforce, sometimes they have all of these clauses because they have spent a lot of their own resources in training these models. So they don't want you to use them commercially. They're good with you using them for any sort of further studies or like research or any sort of further development that you would basically, or they could have like a clause where you have to go back to them and then operate on a commercial model where there could be some sort of other terms and conditions. You have to find out if there is any geographic or domain restrictions. This is specifically important in the case of Europe because of the GDPR laws and the right to be forgotten on the internet. The next question to be asked is, are the prohibited use cases specified? And the last one is API terms compatible with the use case. For instance, this is content moderation deployment. Like if you're flagging fake news, let's say it's content moderation, and the model license says research only. So you will have to find commercial friendly alternatives or you have to negotiate, as I said. Checkpoint 5, liability mapping. Who owns the fine-tune weights? Technically, you would say that you own the fine-tune weights, but when you were fine-tuning, whose data were you using? Who labeled that data? So there's an attribution there. And whose model was the model that you fine-tuned on? Who was the person who fine-tuned, who wrote like the pre-trained model that you fine-tuned on? So who owns the fine-tune weights? Now that question, it seems simple, but the answer is like actually very complex. Who is liable for the model errors? Once you figure out who owns the fine-tune weights, even if you say that, oh, we own the fine-tune weights, basically you want to take 100% responsibility for all of the model errors. You can't go back saying that, well, the data was something that was not very clear, or the instructions that we gave to like all of the data labelers were not clear. You can't say that if you say that we own the fine-tune weights 100%. What if the upstream data is removed? Like what if all of the data that you train your model on the basis of tomorrow is removed? If someone comes up to you and they're like, well, all of this data was wrong. All of the labeling was wrong. And export control issues. For example, false positive flags real news as fake. So if there's like some sort of news that's actually real, but your model's like, well, this news is fake, they can actually sue you. They can be like, well, this caused a lot of defamation, etc. But there's unclear liability between the model provider and the deployer because of like all of the layers. The data is not yours, like completely 100%. Even if it is 100% yours, there was someone who was actually labeling the data. In most cases, it's a third-party vendor. So if you have in-house labelers that were actually labeling the data, in that case, the data set is yours. But then most of the models today are actually fine-tuned versions of pre-trained models. So whose was the pre-trained model and what data was it pre-trained on? So the liability is unclear, in which case the solution is to document responsibility chain and add monitoring. You have to make sure that the upstream data doesn't change. So for instance, let's look at some examples of issues and fixes. The news scraping, it violates terms of conditions of 3 major news sites. So you switched to a licensed news API, where they actually have a license that, oh, we're going to take your data and we're going to share it with all of these people. Again, the licenses could be non-commercial, so you have to make sure that that particular license is actually commercial. The second one is BERT model. So if it's missing attribution in deployment, so you have to add credits to the API documentation. Training data, no license file for label data set. So you have to create a license and attribution MD files. API deployment, terms properly documented. So there's no other needs for like anything else. Some red flags to watch for: public data without checking copyrights, model repos with no license file, fine-tuning models without checking the base model terms. We usually go into a lot of base models, which are available on like, say, Hugging Face or something, and everyone checks like the parameters. They check like, oh, what is this model capable of? What are the new features that this model has? But no one actually checks the base model terms. And usually every model today will actually have a bunch of like different base models that it was pre-trained on to, or like distilled from. So you have to make sure it's going to be like a dependency mapping of sorts. You have to make sure that you understand all of those other models and like all of the data that was actually fed into those models. Lost attribution across Git repos. Like what if someone who is a part of your team leaves your team, or they don't put in all of the attributions or all of the dependency chains. So tomorrow you might deploy your model into production and the data set could be yours, and the pre-trained model, you could have like a bunch of licenses that you know were a part of the attribution chain, but there is some sort of attribution loss just because of various factors like people leaving your team or like teams collaborating with each other or something else. Model repos with no license file. Sometimes there are a lot of model repos with no license files, so you have to actually dig through them if you're going to use the model to figure out what license file they were actually supposed to have and don't. Using research-only models in production. This is a heavy one because it will actually get you sued, including for money from like a bunch of corporates. And assuming APIs will maintain current terms. So a lot of APIs will actually change their terms of conditions. They will just send you an email. It's on you to go back and figure out if all of the terms and conditions that they have come to now are good enough for you, or like will you get sued. So your reusable audit checklist. Pre-development, inventory all data sources with licenses, document model provenance chain, review acceptable use policies. During development, maintain license compatibility matrix, track attribution requirements, document data transformations. Pre-deployment, verify no viral license contamination, confirm deployment restrictions, establish update procedures. And ongoing. Actually, there is an ongoing step. So even after you've deployed, you actually have to make sure that if anything in the upstream changes, you will have to basically monitor it. You have to review compliance for news sources and audit third-party API terms. Some tools and resources. So there's like license scanners. You can do FOSSA or Think Black Duck. Black Duck is one of my favorites. There's a bunch of ML model registries like Hugging Face Model Cards, Papers with Code, modelcards.org, a lot of documentation, and obviously communities including OpenSSF, ML security. So key takeaways. ML compliance requires auditing data, models, and deployments. Use this 5 checkpoint framework for systematic review. Documentation is your best defense against liability. And start compliance early, because retrofitting is costly. Thank you so much. I actually have a QR code out here, so you can check out my framework in detail, so you don't miss any of the checkpoints. Thank you so much.